Hello everybody and welcome back to your video notes. We are covering Learning Target 1.3 Basic, Part B. This is going to get into the meat and potatoes of this learning target. So we are going to learn what you use what you learned in the dimensional analysis intro to convert metric units with prefixes to other metric using prefixes with correct units. Okay? So the things that you should already know are the basics of dimensional analysis, which you just looked at, hopefully, and what your metric prefixes are, which was your previous homework. So in order to convert 123 kilograms to grams, we need to know one thing first of all. And we need to know that 1 kilogram is equal to 10 to the third grams. Okay, and we can flip this the other way. We could have it written like 10 to the third grams is equal to 1 kilogram, and either of these work. All right, so we're going to start with what we're given, which is 123 kilograms, and we know that we're going to try to find grams in the end. Again, I underline what I'm looking for, or what I'm given, and box in what I'm looking for. So I'm going to write my 123 kilograms here. Then I'm going to multiply it by a ratio, and on the bottom of the ratio I want to have my kilograms here, because we know that since the starting number can go over 1, this guy over here can go on the bottom and they'll cancel out. I'm looking for grams in the end, so I'm going to put grams on the top. Now looking over here at my conversion factors, I know that the number 1 goes with kilograms, and 10 to the 3 goes with grams, and we also know that that's really just 1,000. You can write 10 to the 3 over here, or 1,000. I prefer 1,000. And then we can cross out our units. So no, I got kilograms on the top, kilograms on the bottom. They go away. I'm left with grams, which is what I want. And then I multiply it straight across, and then I divide at the end. So 123 times 1,000 is 123,000, and 1 times 1 is just 1. So in the end, I end up with 123,000 grams, and that would be my answer. Now I can always double check, because 123 kilograms I know has to be more than, or that's a lot of grams, right? So that's why we end up with a large amount of grams here. All right, here are 2 more examples, and what I'd like you to do right now is try to pause the video and go ahead and try to do this first one right now. And the second one over here. All right, so here to begin with, I have my 76 hectometers, and I'm going to multiply by some sort of ratio over here. I'm going to have hectometers on the bottom, meters on the top, because I'm trying to get rid of my hectometers. And then that 1 hectometer equals 10 squared meters. So I can come back in here and I can look, okay, hectometer would be 1, and then meters would be 10 squared, or we know that would just be 100. And then we can go ahead and cross out our units as needed. And so that would mean my hectometers go away. I'm left with meters. Multiply straight across. So I end up with 76 times 100, which is 7,600. 1 times 1 is 1. So then I'm left with 7,600 meters. And again, this makes sense because my answer needs to be bigger than 1, because for every 1 hectometer, I get 100 meters. And I've got 76 hectometers, so that means I'm going to have a lot of hectometers in the end. This looks a little sloppy. That should be a 0. Okay? Go ahead and try to do this next one on your own. Pause the video, then come back for your answer. All right, and here's your answer. So the way that I calculated this answer was I started with my 9,012 liters times my ratio. I knew that the liters had to go on the bottom to cancel out the liters on the top. I wanted to get to megaliters in the end, so I put that on the top. And I knew that 1 megaliter equals 10 to the 6 liters, or 1 million liters. or 1 with 6 zeros behind it, liters. And the 1 goes with the megaliter, so I put that there. And then the 1 million goes with the liters. Now this one's a little bit different because I end up having a number other than 1 in my numerator and my denominator. But we do the same rules, multiply straight across, and end up with 9,012 divided by 1 million. And so then if you remember how to multiply and divide by your powers of 10, I end up moving the decimal to the left 6 places because that's how many placeholders this guy here has on the denominator. Or you can type it in your calculator and you get 0.009012 megaliters. All right, so now we've got the similar problem, but it is a little bit different in that we're going to be using our 10 to the negative problems. So we're going to start off just like what we did before. So we've got 213 centimeters times your ratio, and we are going from centimeters to meters. Meters is what I'm trying to find in the end. Put my meters over there. And so centimeters go on the bottom, meters go on the top. And what we know is that 1 centimeter equals 10 to the negative 2 meters. Now this negative business is going to throw us some problems. So I'm going to show you a couple ways to get around that. So the first way is by knowing that 10 to the negative 2, that's really like you move the decimal to the left 2 places from 1. So you end up with 0.01 meters. And then we could come in and put 0.01 meters in here, put 1 for centimeters, and go about the problem. The other way, hold on one second. There we go. We've got another option here. We also know that if I put this in as written, so I've got my 1 centimeter and my 10 to the negative 2 meters. I also know that if I've got a negative exponent, that means it has to go to the other place. So in this case, it would have to go to the denominator, and we'd have to switch things around a little bit. I would put the 10 with the power of 2 up on the, or down to the bottom, and then I'd put the 1 up on the top. And both of these things mean the exact same thing. There's no one better way, whichever way works best for you. In the end, since we're having our units still working and we're using the same ratio, this will work out either way. And I'll show this to you. So if I do 213, and remember I can put this over 1, it means the same thing, multiply straight across, I end up with 213 times 0.01, which when you type that into your calculator, you end up with 2.13 meters. And over here on the bottom, doing the other option, you can put this over 1, still means the same thing. Multiply straight across, I end up with 213 on the top, and 10 squared is simply 100. So if I take 213 divided by 100, I end up with 2.13 meters. Either way gets you the correct answer. That's up to you to decide which one makes more sense to you. Let's do 2 more examples. All right, so go ahead and pause the video right now if you'd like to try these on your own. Otherwise, stay tuned. I'll go through this first one with you again, just like I did before. And then this one over here, I'll just flash the answer at the end and explain it. All right, so here we go. All right, so just like all my other problems, I start with what I'm given, which is 801 nanograms. Multiply by a ratio, you end up getting an answer that's ultimately in the units of grams. I know that 1 nanogram equals 10 to the negative 9 grams. So I come over here and I look and I see, okay, I need my nanograms on the bottom to cancel each other out, and I need grams on the top. So I have to start filling in what I know. And one option is that you know that, hey, this is smaller than 1. So I have to move the decimal to the left 9 places. So I end up with 0.0000000001. Okay, and then that would be for my grams, and I end up with that many grams for every 1 nanogram. Now you can start to see why this isn't necessarily my favorite method, because there's a really long string of zeros and decimals, and it gets a little irritating. But if that way works for you, that's totally fine. I'm okay with that. The other way, and the way that I prefer to do it, is by setting it up the same way. So I end up with 801 nanograms. I can put that over 1, means the same thing. And I still have nanograms on the bottom, grams on the top. And now I just use this base value that I was given. So 1 nanogram equals 10 to the negative 9 grams. And then this negative sign, remember, tells me that I need to change where this is at on my fraction. So in this case, you go from the numerator down to the denominator, and I end up with 10 to the 9 down on the bottom, and I end up with 1 up on the numerator. Okay, it's still the same ratio. All that I did is I just swapped it because of the negative sign. The only time you swap them is if it's the negative sign. All right, let's do calculations and see if we get the same answers. And there we have it. End up with 0.00000801 grams, and the same thing for the other option. Okay, so both options give you the same one. I prefer this bottom one just because it makes a little bit more sense to me as far as having to shift where the exponent goes. A lot of people also like to do it this top way. Both ways work. You choose which one works best for you. Go ahead, pause the video, and try to do this next problem. I will flash the answer here in a couple seconds. All right, and I ended up with the same answers for both problems. And here's why. I know that 1 deciliter equals 10 to the negative 1 liters. 10 to the negative 1 can be rewritten as 0.1 liter. So I come up here and I had this set up with my liters on the top, liters on the bottom, looking for deciliters in the end. So I put my 0.1 liter here and my 1 on the top with the deciliter. Or the way that makes more sense to me is I started with my 10 to the negative 1 on the bottom, and then I shifted that up to the top and made it positive, just like before. And this is what you get. There you have it.